In a nutshell, a PLC, or Programmable Logic Controller, is a ruggedized computer used for automating processes. A DCS, or Distributed Control System, is similar to a PLC in that it has rugged computer controllers. However, the DCS contains multiple autonomous controllers that are distributed throughout a system, also used for automating processes. You may have read that and said, so what's the difference? For the answer to that question, we have to go back more than 40 years. After several years in a corner designing office, this guy named Dick Morley quit his job after asking his employer to allow him to work on Saturdays instead of Fridays, which they declined. You see, Mr. Morley loved to ski, but found that the weekends were too crowded for his liking. Due to financial obligations and such, Mr. Morley and a friend had formed the company Bedford Associates, where they were writing proposals for local tool firms who desired to evolve into the new solid-state manufacturing arena. These proposals used small computers, seemed to be repetitive in nature, and from one project to the next, there were many similarities. Eventually, Mr. Morley got bored with writing proposals because of the repetitive nature, and began to wonder if he could create a controller that could handle these everyday jobs. Actually, during a hangover, Mr. Morley created a draft for a proposed programmable controller and took it to his team. They began designing the programmable controller. After finding financial support, the company, Modicon, was created. Unbeknownst to Modicon, and during the design phase of the programmable controller, a guy from GM had presented a paper, a request, so to speak, for a solid-state controller that would make plants more reliable and durable, which would also replace the hardwired relay systems that were pervasive in the manufacturing industry. As the story goes, sometime later, GM hears about the work being done at Modicon and eventually contracts with them to purchase over $1 million in PLCs. At the time, the controllers were called programmable controllers, and the logic part of the current name wasn't added until the dawn of personal computers, or PCs. Modicon was then baptized and quickly became a business. The name has persevered through a couple of acquisitions, the latest and current being Schneider Electric. In the beginning, the PLC was used primarily for discrete controls. After all, the large purchase by GM for replacing hardwire relay systems. The programming of the PLCs was primarily in ladder logic, which is a format that is very similar to a schematic. The PLC received device information from the field, solved the logic, and then energized the outputs to produce the desired effect. Essentially, the PLC was invented to perform repetitive tasks in a reliable and durable manner. As for the DCS, around 1975, a few companies came out with a version of a DCS. Basically, the creation of a DCS system came about because of the increasing use of microcomputers. There had been other computer-based systems in the industry since the late 1950s, but had limited scopes for scalability, robustness, and security. There were many benefits to a DCS, but one of the primary draws was that an entire plant could be connected via proprietary communications and controlled by a distributed system. For instance, say you had a plant that made an ice cream-filled cookie sandwich. The plant would have a production line for the ice cream, and one of the autonomous controllers would process the batch of ice cream. After the ice cream batch is complete, another autonomous controller may process the freezing of that ice cream. Yet another controller may process the cookie batch, while another may supervise the baking process. With several autonomous controllers, if a controller failed, it would impact only that process, and not all of the others, which led to a robust system that virtually eliminated entire plant failure. The DCS was really good at autonomously controlling single or multiple processes. Another major benefit of the DCS was the integrated monitoring and control system similar to today's SCADA systems. The reason it's a major benefit is that the entire tag base is there, already created for the process control, available to use on the monitoring and control screens. DCS has also had function block programming. Function block programming, if you're not familiar, is a section or several lines of code behind a single interface. That interface may do something like handling the manual and automatic operation of a valve. Function block programming saved a lot of time and redundant programming. Essentially, the difference 40 years ago was considerable, and if you owned a large plant with continuous processes, you likely would have chosen a DCS. In today's industries, the DCS and PLC are quite similar, save for the integrated monitoring and control. With open-source communications, fiber optics, Ethernet, and the like, many PLCs can now communicate with each other and be autonomous PLC that communicate over the network to other autonomous controllers. That wide communication would allow for single or multiple processes being controlled by one PLC to communicate with another PLC. Take our ice cream sandwich example. PLC A could process the ice cream batch. When the batch is complete, PLC A would communicate with PLC B that the process was complete, and PLC B could then launch the freezing process. You can see that with today's technologies, a wide and robust PLC system could do virtually the same thing that the DCSs can do. An advantage of the DCS is installation costs. This advantage occurs because of the location of the autonomous controller to the process can be close in vicinity versus pulling long runs of I/O wire across a plant. Another advantage is the onboard monitoring and control system. One of the drawbacks to the DCSs is the scarcity of programmers that have some experience with a DCS. Most plant floor technicians are familiar with ladder logic programming. However, the DCS programmers and technicians typically need more specialized experience in database functions as well as IT-related networking knowledge. Because of the specialized training, DCS programmers are a bit harder to come by. In speaking of advantages, today's PLC systems can have nearly the same as the DCS, excluding the supervisory control and data acquisition, or SCADA. With a PLC system, multiple PLCs in a plant structure, you still need to create the supervisory and control system. The entire DCS database would be available for the creation of the monitoring and system. The PLC system's individual PLC databases would need to be created in the SCADA system software. There are more programmers available for hire in the PLC arena, and with the new programming languages, such as function block, sequential function, etc., the advantage of function block programming is no longer exclusive to the DCS. This saves in development time when programming a PLC. As you can tell, there are likely advantages and disadvantages in both systems. The takeaway is that with today's technologies, either system can control an entire plant. Which system is chosen will likely take the advantages and disadvantages into account as well as system costs. In summation, the DCS has autonomous controllers dispersed throughout the entire plant. If a controller fails, the entire plant doesn't necessarily get impacted. It also has the onboard monitoring and control that saves development time. A single PLC is a single point of failure. You surely wouldn't want to control an entire plant with a single PLC. However, a connected PLC system can have nearly the same security and robustness as a DCS.